So, to put it plainly, I study hungry supermassive black holes at the centers of lonely galaxies. And I study the loneliest galaxies in places of the sky called cosmic voids. Voids are huge 3D bubbles of space with a very low number density of galaxies. They make up 50% of the universe's total volume, but only contain less than 20% of all galaxies. Over here on the right, you see the catalog of void galaxies, the latest best catalog that we employed in this study published by Dr. Douglas in 2023. And each dot represents a galaxy, and those shaded blue regions are the void regions, and the black galaxies, which are not in those voids, we call wall galaxies, while the red dots are void galaxies. And I hope you can see that those black wall galaxies are much more clustered and clumped, while the red galaxies fill those empty bubbles in between. So my goal was to quantify how common hungry supermassive black holes are in these lonely galaxies to better understand the connection between interactions between galaxies and whether galaxies host an actively snacking supermassive black hole. Instead of the traditional method, which would look at the mid-infrared colors of galaxies, I used 8.4 years of NASA WISE data to look at the mid-infrared variability of galaxies. So how the galaxy's brightness in the mid-infrared changes over time. And using this relatively new method, we were able to identify over 20,000 hungry supermassive black holes that would not be detected using the traditional method. That's because these galaxies show blue mid-infrared colors, which are typically associated with star formation rather than supermassive black holes snacking. And that 20,000 number is about 7% of all of these galaxies that are overlooked in that traditional method.